Good evening everyone. In this video I am taking exercise 2.2 question number 1 first and second part. Before starting this exercise, let us take a few important points related to this exercise. I am giving you general form of a quadratic polynomial ax square plus bx plus c is a quadratic polynomial where a should not be equal to 0. Why it is quadratic? Because degree of this polynomial is equal to 2. Degree means highest power of variable, and here variable is x, right? So here highest power is 2. So degree of this polynomial is 2. That's why it is a quadratic polynomial. And here a should not be equal to 0. If a is equal to 0, then it will become a linear polynomial. Why it will become linear polynomial? See here, if a is equal to 0, then this polynomial will become bx plus c is equal to 0. And highest power degree of the variable is degree of the polynomial is equal to 1. Then it will become linear polynomial. Now let us assume that let alpha and beta are zeros of this polynomial in the form of x, right? And how we can find sum of zeros? Alpha plus beta, it is equal to minus b over a, and product of zeros alpha beta is equal to c over a. One more important point related to this exercise. Suppose alpha and beta are zeros of a quadratic polynomial px, then how we can find this polynomial? Px is equal to x square minus sum of zeros into x plus product of zeros, and this complete polynomial will multiply with k. K means any constant term, or we can write it in this way also: x square minus alpha plus beta into x plus alpha beta. Let us take an example. Suppose 1 and 2 are zeros of a quadratic polynomial px, and I need to know about this polynomial. So px is equal to x square minus sum of zeros into x plus product of zeros, and multiply this complete polynomial by k, where k is any constant term. Now I am taking question number 1, first and second part of this exercise 2.2. Find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficient. And first question, first part is x square minus 2x minus 8. Now compare it with this general form of a quadratic polynomial ax square plus bx plus c. So here a is 1, b is minus 2, and c is minus 8. Now how we can find zeros of this polynomial? First part is to find zeros of this polynomial. See here, coefficient of this polynomial, coefficient of x square is 1. It will multiply with this constant term. 1 into minus 8 is equal to minus 8. Now I need two terms whose product is equal to minus 8, and after doing addition or subtraction, whatever is required here, I need minus 2. You all know about splitting middle term method. So if I will multiply 4 by 2, I will get minus 8, and minus 4 plus 2 is equal to minus 2. I am splitting this middle term. I can write it in this way. Write first term as it is, 1x square minus 4x plus 2x minus 8. Right? Common between first two terms. Here x is common. So x minus 4. Now common between these two terms, plus 2 is common. Take x minus 4 common, then remaining is x plus 2. So x minus 2, x minus 4 and x plus 2 are two factors of this polynomial. And to find zeros of this polynomial, what we will do here, either x minus 4 is equal to 0 or x plus 2 is equal to 0. From here we will get x is equal to 4, and here x is equal to minus 2. It means here 4 and minus 2 are the zeros of this polynomial. Then next part of this question is verification. How we can verify? See, sum of zeros. Sum of zeros, here zeros are 4 and minus 2. So 4 plus minus 2. 4 minus 2 is equal to 2. And one more way to find zeros of this polynomial is equal to minus b over a. So b is here, minus 2, a is 1, so it is equal to 2. Now see, sum of zeros is verified. From both sides, sum of zeros is equal to 2. Then come to product of zeros. Here two zeros are 4 and minus 2. 4 into minus 2 is equal to minus 8. And formula to find product of zeros is c over a. And what is c here? Minus 8. A is 1. So it is equal to minus 8. See here, product of zeros is verified. So in the end you will write hence verified. I hope it is clear to you all. First, how to find the zeros of the polynomial, then verification part, sum of zeros and product of zeros, then come to next part. Next part is 4s square minus 4s plus 1. Now compare it with general form of polynomial. You will get a is equal to 4, b is equal to minus 4, c is equal to 1. Now multiply this first term, coefficient of x, s square, with constant term, we will get 4. 4 into 1 is equal to 4. Now I need two terms whose product should be equal to 4, and after doing addition, subtraction, whatever is required here, I need minus 4. So I can multiply minus 2 with minus 2, I will get 4, and you know minus 2 and minus 2 is also equal to minus 4. Now we will split this middle term, 4s square minus 2s plus 1. Now common between first two terms, 2s is common, so remaining part here 2s minus 1. Common between, I can take here minus 1 outside, it will become 2s minus 1. So here I can take 2s minus 1 common factor, which is in bracket, and remaining are 2s minus 1. So two factors are 2s minus 1 and 2s minus 1. So 2s minus 1 equals to 0, 2s minus 1 is equal to 0. Why I am putting these two factors equal to 0? To find zeros of this polynomial. 2s is equal to 1, s is equal to 1 by 2. Same way here, s is equal to 1 by 2. Now verification part is there. We have two zeros, 1 by 2 and 1 by 2 are zeros of this polynomial. So verification, sum of zeros, 1 by 2 plus 1 by 2, half plus half, 2 by 2, it is equal to 1, and sum of zeros minus b over a, minus, what is b here? Minus 4, a is 4, so 4 by 4 is equal to 1. So here sum of zeros is verified, 1 and 1. Then come to product of zeros, 1 by 2 into 1 by 2, it is equal to 1 by 4. C over a, and what is C here? 1 and 4. So product of zeros 1 by 4, and here also 1 by 4. Hence product of zeros is verified. Hence verification part is done. In my next video we will take first question, third, fourth and fifth part. Thank you very much.